Hello, today we're going to be comparing competitive and non-competitive inhibitors and how they affect enzyme activity. So if we look at competitive inhibitors first, we know that this is the competitive inhibitor. This is our enzyme, our active sites here, and our substrate. First, so what happens is our competitive inhibitor will have a complementary shape to the active site of the enzyme, so that will bind to the enzyme, forming an enzyme inhibitor complex. And then, if you imagine this is as binded there, then it's going to block the active site for the substrate. So the substrate cannot bind to the enzyme anymore. So there's no enzyme substrate complexes formed because the competitive inhibitor has blocked it. So this, if you can imagine here, this is slowing the rate of reaction because we can't form any or no enzyme substrate complexes. However, if we increase the concentration of the substrate, then the hydrogen bonds will break. The hydrogen bonds that would be kind of allowing this to be binded to the active site, those hydrogen bonds would break with the increase of substrate concentration. So the enzyme, the substrate would actually be free to bind to the active site. So this is why competitive inhibitors are actually reversible, which is why on the graph we have, if this line is with no inhibitors, then we still reach Vmax, so we still reach Vmax, but we've reached it slower than we would have with no inhibitors. However, non-competitive inhibitors actually they bind to the allosteric site, which is just another site on the enzyme. So this is the allosteric site. So this isn't blocking the substrate from binding, but remember we've bound to the allosteric site, and that is going to form an enzyme inhibitor complex. And by binding to the allosteric site, the non-competitor inhibitor is actually changing the tertiary structure of the enzyme. So we've got a change to the tertiary structure of the enzyme. Remember, because an enzyme's a protein. And then because the tertiary structure has changed, that's going to then change the shape of the active site. So this now actually won't be complementary, because once this is binded, the shape could change, so it could change so it'd be a point there or whatever. So